Hello guys, this is Himanshu from Code Campaign and we are continuing with recursion problems. So today we are going to discuss about a very famous problem which is rat in a maze. Okay, so what rat in a maze problem is? So suppose you are given this maze. In this maze, one represent that there is a place one represent that you can traverse on this cell, like you can stand on this cell. So suppose you have one in the two consecutive cell, that means you can move from this cell to this cell. And 0 represent that this cell is blocked. You cannot move on this cell. So from here to here you cannot move. This cell is blocked. So all the 0 represents blocked cells. Okay. So these are all your block cells, and all the 1 represent the cells on which we can actually move. Okay. So what this problem says, suppose this is your maze, you will be given a starting point. So suppose this is your starting point. You will be given a ending point. Suppose this is your destination or ending point. You have to find a way to reach from start to the destination, right? So if you see in this problem, you have this way to reach to your destination. Okay, and we also have this way to reach to our destination. Okay, what are the constraints of the problem? We can make move in left direction, right direction, up direction, and down direction. So if we are on this cell, we can move in left direction, we can go in right direction, we can go in up direction, and we can go in down direction. Remember, we cannot move diagonally. So we have only 4 move possible. So if you have watched the video on the Google problem, my previous video, in that problem we could have moved in diagonal direction also. Like there was the independence to move in diagonal direction. So that's why we had 8 different moves in that problem. But here we can move only in 4 direction. We cannot move diagonally, right? So we have only 4 moves: left, right, up, down. Okay. The other constraint is we have to go from source to destination. We have to find a path. The other constraint is we cannot visit the already visited cell. Um, so what does it mean? Suppose we are coming from here to here, we are going here. Now we cannot go back on this cell again. Okay, because we already included this cell in our path. So we cannot traverse the already visited cell again. Okay, so this is the third constraint. Okay, so if you remember in our last problem, we used backtracking to solve the problem, and this problem is also similar to the previous problem. In the previous problem, Google problem, what we had to do, we were given the board of jumbled characters, and we had to find the characters which are valid and present in the present in the dictionary. So in that problem, what we had to do, we have to generate all the combinations possible from those characters which were present in the board. If you haven't watched the problem, Google problem, I think before proceeding through this video, you should go back and watch that problem because that problem and this problem both are very much similar. Now, in this problem, what we have to do, we have to again do the same thing. We have to try multiple paths until we reach our destination. So there are multiple paths. So we have to try all the possible paths, and then we have to print the path which will take us to our destination, right? So we'll use backtracking here again to solve this problem. So in Google problem, what we did initially, we wrote down our moves, right? What are our allowed moves? So in that problem, we had 8 moves. So in this problem, we have only 4 moves. So we'll again find like how what will be our moves in this problem. Okay. So suppose we are on this cell. So the coordinates of this cell will be 1, 2, 3, 0. Let's remove all this. Okay. So 0, 1, 2 3 0 1 2 3. Okay, so the coordinates of this cell will be 1 comma 2, right? So suppose we want to move in the left direction. What we have to do, we have to subtract the column by 1, because the coordinate of this cell will be 1 comma 1, right? So we have to subtract our column by 1 and our row will remain same. Okay, now next move will be, suppose we want to move in the right direction, so we have to increment our column by 1, row will remain same. Suppose we want to move in the up direction, so we have to decrement our row by 1 and our column will remain same. Suppose we want to move in down direction, then we have to increment our row by 1, column will remain same. Okay, so these are the four possible moves that we can take. Okay, so now let's go ahead and write the code. Okay, so let's go into our ID. So this is where we left in the previous video, right? So we solved the Google problem. Okay, so let's run it and check. Yeah, okay, so now let's go ahead and write the solution for this problem. Okay, so find path in maze. What we have to do, first we have to pass our maze, then we'll pass our again two-dimensional visited array, right? We'll pass our current row and column. We'll also pass our destination row and destination column. We'll also pass move. Okay, so what, so this is our maze, two-dimensional. This is our visited uh, visited two-dimensional array. So this array will represent the path and this array will also represent the cell we have already visited. So let's see it in example. So let's put one more. Okay, so what we'll do, so suppose this is our visited two-dimensional array. So we'll initialize it with all zeros. And then when we are moving from one cell to other cell, we will replace this zero with the move number that we are taking. So this is our first move, so we'll replace from first here. Then if it is our second move, we'll replace it with the second here. Third move, we'll replace it with the third. Okay, so this is the use of our two-dimensional array. Now let's write our terminating condition of recursion, right? So our termination condition will be when we'll reach our destination, right? So this is our termination condition, and what we have to do, we have to print the path, right? So we'll print the path. Our visited array has 4 rows and 4 columns, right? So we'll print all the rows and all the columns of the visited array. So visited, then after printing one column, we'll add one new line. So, and after printing one complete path, we'll add one delimiter. So at least we'll be able to segregate the multiple paths, right? Just simple delimiter. Cool. So this is our base case of the recursion or the termination condition of the recursion. Okay. So now let's write our logic. So what we have to do first we have to write our moves, right, that we are going to take. So our moves will be so we can take only 4 moves here, right? Left, right, up and down. So these are our 4 moves that we can take, right? So this is we are incrementing the column, so we are going right. This is we are going left. This is we are incrementing the row, so we are going down, and here we are decrementing the row, so we are going up, right? So yeah, let's go through all these paths. Okay, now we'll generate our new row index, so previous row index, and we will add one move here, and we'll generate our new column index as well. Cool. Now what we have to do, we have to validate if these index are valid index or not, right? So what we have to validate here, we have, so this was our, oh, let's go back here. So this was our maze. So what we have to validate, we have to first validate if the new row that we are generating and the new column lies inside this board, right? So this should be this, and this also should be this. The second thing, we have to validate that whatever news coordinate corresponds to, it should not corresponds to the cell which is already blocked, right? So we have to check if maze row column is not equal to 0, then only it's a valid thing. The other thing that we have to check, we should not have visited this particular cell already, right? So cannot visit the already visited cell again, right? So let's go back here in our code, write one validate function. So can we move? So what it will take as input, it will take our maze, it will also take our visited two-dimensional array, it will take our new row index and new column index. Okay, now we'll validate, right? So first we'll validate our new row index should be inside the board. Same, we'll check for the column as well. Then we'll check if the this index is should not be blocked. So this should be, or I should say this should be equal to 1, and we should have not visited this cell already, right? So this should be equal to 0. If all these conditions satisfy, then we'll say okay, this is a valid index that we can travel. Otherwise we'll say we cannot travel this index, right? Okay, so let's call this function here. Can we move to pass maze, then visited, then our new row and new column. Cool. So if this returns true, then what we'll do, we'll increment our move and we'll update our visited array with that move, and then we'll call the same function again to validate if we reach the destination or not, right? So maze visited, our destination row and column will remain same, and then we'll pass move here. Okay, now after this, while coming out of recursion, we will again decrement our move and we will again clear the visited cell. Okay, so yeah, that is the code. So let's go ahead and run this code and check if this works. Okay, so I've already, so this is the maze that we took in the example. This is the maze, and then we have initialized our visited two-dimensional array with all zeros. Let's call the function, pass all these parameter here. Visited. Suppose we are starting from 0, 0 and our destination is to reach 3, 3, and initial first move we are taking, and we have to also update our visited array 0, 0 cell with first move, right? Because we are taking the first move. Cool, let's go ahead and see if this program works. Okay, it's not printing anything. I think there is some problem in our code, so let's go back and check what went wrong. Comparing here, then we're okay. This is some bug here. We should be printing I, j. Passing index here, checking if we can move, passing the move here. This looks right now. So let's go back and run this thing again. Maze. Okay, let's run this again and check. Again, we are getting a blank screen here. I think there is some big problem in our code. Let me find it again. Okay, so yeah, this. Okay, so first we have to stop debugging. This should be 4 and this should also be 4 because our two dimensional array is of this is of 1 2 3 4 length. Cool. So let's run it again and check if we get the output. Okay, we got some output here. Okay, let's make it more visible, so we'll put one comma and space, so at least we'll be able to see it properly. Okay, so now this is, we can see, so this is our one path. So at move 1 we went to 0 comma 0, at move 2 we went to 0 comma 1, then move 3 4 5 6 7. So yeah, so this is one path and the other path is 1 2 3 4 5 6 7, right? So if we go back to our problem now, so as we can see, so this will be one path. Let's put it just into this. Okay, so yeah, so this is one path which is says 1 2 3 1 2 3 4 5 6 7, and the other path is 1 2 3 4 5 6 7, right? So our code is working fine, it's printing the right solution. Okay, so now let's discuss one more thing before concluding this video. So we have written we have discussed 3 problems so far in the recursion, right? And we have solved all those problems by using backtracking. The first problem was permutation of the string, the second problem was Google, finding the word, and the third problem is finding the path in the maze. If you look closely to all these problems, you will find some similarity. So all the backtracking problem follow this template. Okay, so let me put this here side by side, both of the things, so at least we'll be able to see code properly. Okay, so let's go up. Cool. So let's discuss it with the Google code. So what backtracking template says, it says the termination condition will be if we found a solution, then we display the solution. Here in our Google problem, what is the termination condition? When we founded the word and then we printed the word, right? Then the second thing is we will go for all the paths. So here again we are going for all the paths or moves. Then we will check, we are generating the new coordinate by using the move, and then we are checking if that move is valid, which is same. Here we are checking if the move is valid. Then we are applying some values, like we were updating the cell we already visited, right? We are making it true, and then here also applying some values, and then we are making the call to the same function, and here we are making the call to the same function. While coming back from recursion, we will remove the values, and here we reset the value to false, so we make the visited cell unvisited. Now let's see if our the problem maze problem also follow the same template. So if you see here, this is our termination condition and it says found a solution. This is our found a solution condition, and then here we are printing the results. Here we are going through all the paths, which is this, and then we are generating the coordinates of the new cell by using our moves, and then we are checking if that move is valid, right? Then we are applying some values, like we are incrementing our move and putting that move onto the cell that we are visiting, and then we are calling the function for the recursion like we are calling here, and then again we are resetting the values. So all the backtracking problem follow this template. So if you remember this template, you will be able to solve most of the backtracking problem. So that's all for this video. If you haven't subscribed to my channel, please go ahead and subscribe. I will post couple of more problems into the recursion series, and then we'll move on to some other data structure, and we'll solve some different problems regarding different data structures. Thank you.